In examples 3 and 4 in the Module 3 class notes, we've got more fractions, more rational expressions, more factoring, yay fractions, yay factoring. Lots of practice here. Let's get down to it. The difference now in examples 3 and 4 is that we are taking two rational expressions and multiplying them together. So it's about remembering how to multiply fractions. And if you need to ask questions on that or go back and review that material, absolutely do so. But multiplying fractions is probably the simplest of the operations on fractions, and that is you just multiply straight across. You multiply across the numerator, you multiply across the denominator. The easiest way to do that with rational expressions, because I'm looking at these two fractions and thinking about multiplying across the numerator and across the denominator, that would be a lot of multiplying. Easier path to take would be to factor and try to simplify as much as possible as you combine these two fractions. So we've got lots of factoring to do here. We've got 4 polynomials that we need to factor, and you know how to factor, or you can go back and review the factoring techniques that we've talked about. Definitely want to do that. But here are the results of factoring each one of these 4 trinomials. Well, one of them is a binomial, but factoring each of these 4 polynomials, and you should make sure that you understand how to get these factors and not just take them from me as your instructor. But we've got x minus 3 times x plus 2 over 2x minus 3 times x plus 2 for the first fraction. In the second fraction, 2x minus 3 times x plus 5 over x plus 3 times x minus 3. And now we can think about multiplying straight across and canceling any common factors that we have in the numerator and denominator, like x plus 2 and x plus 2 in the numerator and denominator of the first fraction. But since we're multiplying straight across, we can think of everything in the numerator, both numerators, as being in the numerator, and everything in both denominators as being in the denominator. So I can do something like recognize this 2x minus 3 in the numerator will reduce with this 2x minus 3 in the denominator. And similarly, this x minus 3 factor in the numerator will reduce with this x minus 3 factor in the denominator. And once I factor and reduce all the common factors across the multiplication, then I'm left with something relatively simple in this case, which is the only factor that didn't cancel in the numerator was x plus 5. And in the denominator, that would be over x plus 3. And that is my simplified form with no more common factors. One more example of multiplying rational expressions, this time with trinomials that might need to use the AC method to factor. We reviewed the AC method in our first example video in this Module 3 series, and the AC method was covered in our Module R review of prerequisites as well, so go check that out and make sure you understand where I'm getting these factors from. The numerator of the first fraction factors to 2d minus 5 times d plus 7. The denominator, d plus 7 times d plus 3. The numerator of the second fraction factors to 3d minus 7 times d plus 3. And the denominator of the second fraction, 3d minus 7 times d plus 7. Now, just like we did in example 3 on the last slide, we're going to find factors. Since we're multiplying these fractions together, then we're considering them all as one single larger numerator and one single larger denominator, and find what do we have that reduces, what common factors do we have, like the d plus 7 in the numerator here with the d plus 7 in the denominator, and the 3d minus 7 in the numerator here with the 3d minus 7 factor in the denominator here. Even across fractions, I see a d plus 3 in the numerator and denominator. Those will reduce, those will cancel. But what won't reduce is the d plus 7 here with the d plus 7 in the numerator here. Not because they're on different fractions, that there's nothing wrong with that, but I've already canceled the d plus 7 in the numerator with a d plus 7 factor in the denominator. So I can't use it twice. I can only cancel once. So that d plus 7 that I've got underlined in green then stays, as does the 2d minus 5 in the numerator. And there's my reduced fraction.